This is Srinivasan, Assistant Professor, Department of ECE. So in this presentation, we are going to discuss on the various Verilog features that makes us to write a hardware description language program as easy as possible. When it comes to Verilog language features, it starts with the various operators. So we have arithmetic operators, so unary sign plus, unary sign minus, plus, minus, multiply, divide, modulus, and exponential. Also, we have the logical operators like logical negation, logical and, logical or. And we have the other operator like bitwise operator where we can perform the bitwise operation of not, NAND, so not and, or, exclusive or, and exclusive NOR. So when it comes to logical versus bitwise, so we can go with comparing two data of more than 1 bits. When it comes to bitwise, we can perform the bitwise comparison of the positions of the data. And the other operators which the Verilog language features are not equal, equal, greater than or equal, lesser than or equal, greater, less, etc. And when it comes to these numbers, it returns whether it is true or false. The other features are operators where we can have shift right, shift left, and arithmetic shift left, and also reduction, conditional, concatenation, and replication operations also available. It supports 4 value levels. So value 0 is equivalent to logic 0 state, value 1 equivalent to logic 1 state, X unknown logic state, Z high impedance state. And it also includes the module as the basic unit of hardware in Verilog. So it cannot contain definitions of other modules, can be instantiated with another module with respect to hierarchy of modules. As I already said, Verilog HDL program starts with module and ends with end module, and module followed by module name, the list of ports. So once the list of ports is declared, we need to declare the input and output declaration with respect to the various ports or the variables. And you need to go with local net declaration where we used to declare the temporary connections like wires which are the intermediate outputs within the logical diagram. Then it starts with the parallel statements. So it will start with 1 by 1 and the program will continue. And here comes a module AND function where we are giving a module and we are claiming the module name as AND. T1 is the output, A and B are the two inputs. Assign T1 is equal to A and B. So this simple HDL program will perform or will logically verify the AND function of the logic gate. So another example, we go with a combinational circuit. So we have 4 inputs A, B, C and D and 1 output F and 3 logic gates and 2 intermediate values T1 and T2. So to start with module, you can go with the name as 2 level. So the variables are A, B, C, D and F. Inputs are A, B, C and D. Output is F. And we have 2 intermediate outputs T1 and T2 that should be declared as wire. So T1 comma T2. So now we can start with assign T1 is equal to A and B and T2 is equal to negation of A or B, and assign F as negation of T1 and T2. So this will perform the logical verification of the circuit shown in figure. When it comes to other Verilog features, we have data types. One we call it as net, wire, WR, WAND, try, supply 0, supply 1, etc., which are used to refer the intermediate values within the circuit. And the next is register, integer, real or time. So which is used to represent the output that can also act as an input within the circuit. So when it comes to other Verilog language features, it includes data types like integer. So you can include integer in your program, and c is equal to x plus y, and x plus y, the output will be an integer value. Vectors, we can declare vectors. For example, a 8-bit value can be declared like wire 7 down to 0 sum, and 1 down to 0 as data. Even you can declare your clock as a register. The other features, the constant value, it can be sized or unsized form. 4 tick B 0101 represents, it is a 4-bit binary value and it corresponds to 0101. 1 tick B0, a single bit value, 0. 12 tick HB3C is nothing but 12 tick means 12 bit value, and it is a hexadecimal value. B3C corresponds to 1011, 0011, 1100. Similarly, 12-H8XF, 25, a signed number, can also be declared in Verilog. So parameters is another Verilog feature where you can declare a constant with given name. So for example, HI is equal to 0, LO is equal to 0, and even you can parameter up is equal to 2 tick B00, which means up is equal to 00, down is equal to 01, steady is equal to 10, and it can be used within a main program. When it comes to Verilog language features, predefined logic gates can also be implemented or used within the Verilog HDL program. So 2 input AND, 2 input OR, 2 input XOR, and it even supports 4 value levels. The next Verilog is by using primitive gates. So by using the keyword AND, NAND, NAND, OR, NOR, NOR, XR, XNOR, NOT, these logic functions can be used within the program so as to achieve the function of those logic gates. So 2 ways to specify the connectivity during module installation, right? A module within a module can be done where we call it as positional association, implicit. The other one is explicit association. So let us go with an example. When it comes to positional association example, where we design a full adder using 2 off adder modules. So off adder, it is a 2-bit adder. It performs the addition of 2 bits. A full adder is one which performs the addition of 3 bits. So we can realize a full adder by using 2 off adders. For this, we can write a program for off adder, and the off adder program can be accessed in the main program of the full adder, and it can be implemented using 2 off adders and a OR gate. So let us start with off adder. So here is your off adder with 2 inputs A and B and 2 outputs sum and carry. G1 is gate 1, G2 is gate 2. So as usual, we need to start with module, and we are giving the name off adder. So the ports are sum, carry, A and B. A and B are inputs and carry and sum are output. And we are using a XOR gate. So the gate name is G1. The obtained output is sum, A comma B. And next is AND gate 2, carry comma A comma B in module. So now we have written the program for off adder, and what we are going to do is we are going to write a program for full adder by using the off adder module. Right. So off adder module, we have given the name as off underscore adder. Right. So now we are going to write a full adder module. The name is full adder. Sum C out, A comma B comma C in. A, B and C in are input, and output is C out and sum. And we have intermediate value W1, W2, W3, where we are recalling the off adder HA1 for the values W1, W2 and A comma B. Similarly, off adder HA2 sum comma W3 C in comma W1. And we need a OR gate so as to obtain the C out W2 and W3. So by calling the off adder module in a full adder module, we can implement a full adder circuit using two off adders and a OR gate. And next, explicit association. So where we can declare the variables explicitly. So that is with respect to a full adder using two off adders. So where we represent W1 and W2 is nothing but the intermediate sum and carry, and the second off adder is called so as to produce the final sum and final carry. Thank you.